And now we're going to look at an example of calculating this line of best fit, this linear regression line, using a TI Inspire calculator. This is a TI Inspire CX2T, but they're all going to be more or less the same. It's the same buttons. Everything looks pretty much the same. Let's look at our example. We have these tomatoes were sprayed with a pesticide fertilizer mix. The figures in the table give the yield of tomatoes per bush for various spray concentrations. They have told us that this is our X and this is our Y, but if they hadn't, we would have to think about which thing probably causes the other one to happen. Of course, linear regression absolutely does not tell you about causation, but when we're putting it on a graph, usually we have an idea of which direction the causation goes, and you want to put the independent variable on the X-axis, the one that probably is causing the other one to happen if there's a causation happening at all. So our independent variable here is the amount that's sprayed. I spray however much I want on my tomatoes, and then I see what happens. So the independent variable is X, the spray concentration, and the dependent variable is Y. And if you have any trouble figuring out what is the independent and dependent variable, try filling out the sentence, blah, blah, depends on the other one. And here you're just going to put in the different ones. So does it make sense to say the amount you put on the spray depends on how many tomatoes there are? I don't think so. Like, the tomatoes are not causing me to go back in time and change the amount of spray I put on the tomatoes. Instead, I would say it's the other way around. The number of tomatoes I have depends on how much spray I put on in the first place. So the tomatoes depend on the spray. Tomatoes are the dependent variable. Tomatoes go on the y-axis. In part B, it wants us to draw a scatter plot of the data. I'm going to go ahead and do that on the calculator. We've done this before. So I want to go to lists and spreadsheets. Because I intend to create a scatter plot, I have to name my variables. If I just want to do calculations, I can refer to the column names A and B. But if I want to do a scatter plot in this calculator, I have to name them. So here I'm going to put spray. That's not how you spell it. Notice that it's still in italics. If ever you're typing something and it comes out bold, or even like straight up and down values, you have to keep going. This means something to the calculator and you can't use it. I would need to put like more letters to get it back to italics, or maybe fewer letters so it's italics. But you need this to be italics. If it goes straight up and down, or if it turns bold, that means it means something and it's going to like ruin your whole page. So here we can go with spray, and here I'm just going to go with Tom for tomatoes. Here I have to put all my data. I can't see it, so let's go ahead and move this down here. We have 2, 4, 6, 8. 10, 12. And here, 45, 76, 103, 105, 119, 124. I missed that one. Do I have any typos? Always check for typos. They're really common, and then it's unfortunate. Okay, it looks good. So I can make a scatter plot. I go to the on button, and I go to this pink chart here. I have to bring my mouse down to the bottom and choose my independent variable, my X variable, which was the spray. Come over to the side and make the Y, which is the yield of tomatoes. Yeah, this is okay. It looks actually a little bit like it's starting to make a curve, so I'm not super confident that's a linear correlation, but it's not so bad. So I could definitely say this has a strong positive linear correlation. However, I would actually like more data because I suspect that it flattens out at the top. Like, there's a maximum amount of spray that's useful. It said to draw a scatter plot. We have done it. Now we want to calculate the regression line. I can and I will do it inside the scatter plot just to show you. But in my life, if I want to be doing useful things, I will not do it in the scatter plot because I can't use it without typing a bunch of numbers. But if I intend to do it here on this plot, I want to go to Menu, Analyze, and come down to Regression, because remember, a line of best fit is a linear regression. I have two options. They're the same. Notice the difference is just like which letter is connected to the X and which one is all by itself. Typically, we will use MX plus B. MX plus B is like the US form. MX plus C is what the British form is. Often in statistics, we use A plus BX, but like that's not what we're doing today. We're just very much Millier's program IB math, sticking with MX plus B. And it just puts it right on there. I think I have mine set to auto as my number of display digits is auto. If this were fewer, I think most people's is by default on float 3. I would get it rounded like this, which for IB is great because this is already 3 significant figures. So I could write this down as my answer for the regression line. However, if I want to use this, I really do want more decimal places. And to be really honest, I want to use all the decimal places. I don't want to use this graph to do my calculations because I want to know what all the digits are. So now I've seen it. It's great. I have what I could write down, but if I intend to use it, I will calculate it elsewhere. Let's take a look here first at part D, because I haven't answered that. It says, give an interpretation for the slope, also known as gradients, and the vertical intercept, also known as the y-intercept. So the slope here, the gradient is 7.66. This means that the y increases by 7.66 for each one in the x. So I expect my yield of tomatoes per bush to be 7.66 more tomatoes for every additional milliliter per 2 liters of spray I have here. And then the y-intercept is 40.1. It means if I don't use any spray at all, 0 on this x-axis, I expect the y to still be 40.1. So if I don't use any spray, I expect to get 40.1 tomatoes per bush. And now let's actually use our regression line. As I've said too many times now, I don't like to use this regression line here. I don't know why it's not useful. Take it up with TI. I don't know why they made it work this way. But in order to get like a functioning variable inside my calculator that I can use, I need to do the linear regression inside the spreadsheet. It's much the same. I'll go to menu, statistics, stat calculations. And again, I want to come down to this mx plus b linear regression, x lists. That was the variable. I press the right button to get my list of variables, spray. Tab to go down to the next one. I press to the right and I choose tomatoes. Notice here, F1. It's going to be F something because this is a brand new sheet for me. Is F1, depending on if you've been using your calculator a bunch, it might be like F4, F5, F23, doesn't matter. Take note of this in your mind. It's going to save it so that we can use it, which is the thing that's so great about doing it in the spreadsheet. Make sure to scroll down so that your results column is not going to write on top of the values you already have. I put stuff in A and B. C is fine. So I press OK, and here I have it. That is the same M, 7.66 rounded. That is the same B, 40.1 rounded. I can go down, and there's my R value. It's nearly perfect, positive linear correlation. I have all this, but I want to use it. In part E, it says, use the equation of the line of best fit to predict the yields if the spray concentration was 7. So if the X was 7, what would I get? If I were to do 7.56714, and then however many decimal places are after this, times by 7, plus 40.0667, whatever the decimal places are, that's going to give me my estimated Y. But I prefer to do that on a graph. So I press on and I go to like our normal graph, not the stats graph, but like the regular function graphing. And notice it automatically put me on F2 because it's saved. Press the up button. It saved it there with all of its glorious decimal places. I didn't want to type these by myself because I'm lazy. I wanted the calculator to do it for me. That's the whole reason I forced you to go back to the spreadsheet to do these. So I press enter. It graphs it. It looks not great. I don't love it. Probably I'm going to change my window to match what I have up here. So menu, window settings. In my data from my table, the X goes from 2 to 12. So maybe I'll go from 0 to 14. 15 I typed by accident. That's fine. In my table, the Y's go from 45 to 124. Typically, you want to start at 0. That makes a good chart. You don't really want your charts not to show the x-axis. And the max on my table is 124, so maybe I put 150 so I can see a little bit higher. That's what my line looks like. I don't have my scatter plot. That's different to this. Here it is. Here I can see the data points. Here I just have the line, but I'll use it for predicting. So we wanted to know what happens if X is 7. Menu, trace graph, and I just type 7, enter. 93.6667. Again, mine is by default on auto. If you want to have fewer decimal places, you can change this to float 3 is the standard. That's going to give you 3 significant figures. Same regression line, 7.66x plus 40.1. And now my y coordinate is 93.7. So based on my regression line, if I used a concentration that was 7 milliliters of of fertilizer pesticide per 2 liters of water, I would expect to have 93.7 tomatoes per bush. The question is this valid? Comment on the reasonableness of this prediction. Is it interpolation or extrapolation? Is 7 in between my X values that I was given between 2 and 12? Yes, it's interpolation. It's fine. This is probably a fairly reliable estimate.